Late September 1944, near the village of Arracourt, France, German Panzer commander Hauptmann Ernst Becker watched through his periscope as an American tank destroyer materialized from behind a farmhouse, fired once, and disappeared before his gunner could even traverse the turret. The entire encounter lasted 174 seconds. His Panther tank, pride of the Wehrmacht, sat burning, and somewhere in the autumn mist, moving at a speed no tank destroyer had any right to achieve, the Americans called it the Hellcat, and it was rewriting every rule of armored warfare the Germans thought they understood. Before we jump back in, tell us where you're tuning in from, and if this story touches you, make sure you're subscribed, because tomorrow I've saved something extra special for you. The morning of September 19, 1944, began like any other for Kampfgruppe von Luttwitz. Their column of Panther tanks from the 113th Panzer Brigade rolled through the Lorraine countryside with the confidence of men who believed in their equipment. These weren't the green crews of 1943. These were veterans, survivors of the Eastern Front, men who had faced T-34s and lived to tell about it. Oberfeldwebel Klaus Zimmermann commanded the 2nd Panther in the formation. He had been a tanker since 1941, had fought at Kursk, had survived the retreat from Ukraine. His crew was tight, professional, experienced. They knew their machine inside and out, knew its strengths, its weaknesses, knew how to angle the armor, how to use terrain, how to fight. The road wound through gentle hills dotted with apple orchards. Morning fog still clung to the low ground. Visibility was perhaps 400 meters, maybe 500 in places. Not ideal, but workable. Zimmermann's radio crackled with routine chatter. The lead tank reported nothing unusual. The reconnaissance unit ahead had seen no enemy movement. Then the world exploded. The lead Panther erupted in flames so suddenly that Zimmermann's mind couldn't process what he was seeing. No muzzle flash, no warning, just the catastrophic detonation of ammunition as a 76mm armor-piercing round punched through the side armor and found the ready rack. The tank commander, a man Zimmermann had known for 2 years, never made it out. "Contact right!" Zimmermann's gunner screamed, already traversing the turret. But traversing to where? There was nothing visible, just smoke, just fog, just the burning wreck of their lead tank. Then Zimmermann saw it. A low, angular shape emerging from behind a stone barn perhaps 600 meters away. It was moving. Fast. Impossibly fast for an armored vehicle.
His gunner acquired the target. The Panther's gun was still turning, the hydraulics whining as they brought the 75mm KWK-42 to bear. They were good, they were fast, but not fast enough. The American vehicle fired first. The round missed Zimmermann's tank by less than a meter, the shockwave actually rocking the 45-ton Panther on its suspension, and then it was gone. Not destroyed, not disabled, just gone. The shape vanished behind a hedgerow, moving at a speed that defied belief. Zimmermann had seen American tank destroyers before, the M10, slow and lumbering. This was something else entirely. His gunner fired at where the target had been, the round impacting harmlessly into the earth wall of the hedgerow. "Did you see how fast that moved?" his loader whispered, his voice tight with something that might have been fear. Before Zimmermann could answer, another Panther in the column exploded, this one 200 meters behind them. The Phantom had circled the entire formation in less than 2 minutes. His radio erupted with confused shouts, contradictory sightings, panic barely held in check. The Americans had found something that could dance around Panthers like a boxer around a heavyweight. By the time the engagement ended, Kampfgruppe von Luttwitz had lost 4 Panthers. They had not destroyed a single American vehicle, not one. The survivors reported the same thing. Incredible speed, rapid fire, and then nothing but empty landscape. Tank commanders who had faced the best the Soviets could field found themselves utterly outmatched by an enemy they couldn't even see long enough to shoot. 3 days later, in a commandeered chateau 30 kilometers behind the front lines, Officers from Panzer Group West gathered around a map table. The room smelled of cigarette smoke and bad coffee. The mood was grim. In 72 hours, they had lost 23 tanks to an enemy they barely understood. Major Otto Richter commanded the intelligence section. He was a meticulous man, a former professor of engineering from Stuttgart who had been drafted into analyzing enemy equipment. Before him lay a growing file of after-action reports, all describing the same impossible vehicle. "Gentlemen," he began, his voice cutting through the murmur of conversation, "we are facing something unprecedented. Based on reports from 15 separate engagements, we are dealing with an American tank destroyer that can achieve speeds in excess of 80 kilometers per hour on roads, perhaps 60 to 65 cross-country." The room fell silent. Those numbers were absurd. A Panther could manage 46 kilometers per hour on a good road, a Tiger barely 38. The idea of an armored fighting vehicle moving at automobile speeds seemed like fantasy. "That's impossible," someone muttered. "No tracked vehicle can move that fast."
And yet, Richter continued, spreading photographs across the table, we have multiple confirmed sightings. Reconnaissance aircraft have photographed them. We even have one witness who observed the vehicle up close before it withdrew. The Americans call it the M18. Our crews have started calling it the Hellcat. The photographs were grainy, taken from high altitude, but they showed a vehicle unlike anything in the German inventory. Low profile, open-topped turret, long gun, and clearly unmistakably fast. The tire tracks in one photo showed the vehicle had been moving at high speed when it made a sharp turn, the earth torn up by the violence of the maneuver. Richter pulled out another document. We've analyzed engagement patterns. The M18 uses what the Americans call shoot and scoot tactics. They appear from unexpected angles, fire 1 or 2 rounds, then withdraw before we can return fire. The entire engagement lasts on average between 2 and 4 minutes. Our crews are reporting they have approximately 3 minutes to acquire, aim, and fire before the target simply vanishes. He let that sink in. 3 minutes. For a Panther crew to spot an enemy, traverse the turret, acquire the target through the gun sight, range the distance, and fire was a process that took time. Even excellent crews needed 20 to 30 seconds under ideal conditions. But these weren't ideal conditions. The Hellcats appeared at unexpected ranges from unexpected directions, and they never stayed still. "What about armor?" asked Oberst Dieter Vogel, commander of the 111th Panzer Brigade. "Surely something moving that fast must be lightly armored. One good hit should destroy it." Richter nodded. "Intelligence suggests the armor is minimal, perhaps 25 millimeters maximum. Any hit from our 75 millimeter gun would be catastrophic. But therein lies the problem, gentlemen. We cannot hit what we cannot see, and we cannot see them because they refuse to remain visible long enough to engage." He pulled out a tactical map, marked with dozens of red X's indicating tank losses. The pattern was clear. The M18s operated in small groups, 2 or 3 vehicles working together. They would strike from multiple directions simultaneously, creating chaos and confusion. By the time German tanks oriented to face one threat, another would appear from a different angle. And when the Germans tried to concentrate fire, the Hellcats would simply withdraw, moving faster than any pursuit could follow. Their gun appears to be a 76 millimeter, high velocity, capable of penetrating our side and rear armor at combat ranges. The frontal armor of a Panther appears to stop them, but only if the angle is favorable. And they are not fighting us frontally. They are using their speed to get flanking shots, to hit us where we are vulnerable. Vogel studied the map, his face darkening. "So we are facing an enemy that can penetrate our armor, but we cannot catch, that appears and disappears at will, and that is systematically destroying our formations piece by piece."
"Yes, Herr Oberst, that is precisely the situation." The room erupted in discussion. Tactical suggestions flew back and forth. Some officers advocated for tighter formations, better coordination. Others suggested aggressive reconnaissance, trying to spot the Hellcats before they could attack. A few, the realists, simply shook their heads. They had seen this pattern before on the Eastern Front, when new Soviet equipment appeared. The initial shock, the desperate scrambling for countermeasures, the slow realization that the enemy had achieved a fundamental advantage. "We need to capture one," Richter said quietly, but his voice carried authority. "We need to examine this vehicle, understand its systems, identify its weaknesses. Until we know exactly what we are facing, we are fighting blind." Vogel nodded slowly. "Make it happen, Major. Whatever resources you need, you have them. We cannot continue losing tanks at this rate. The Americans are already breaking through at multiple points. If we cannot stop these Hellcats, the entire front will collapse." That night, Richter sat alone in his makeshift office, reading reports by candlelight. The chateau's electricity was unreliable, knocked out by American artillery during the day. Outside, he could hear the distant rumble of guns. The front was only 15 kilometers away now, closer every day. He pulled out a personal notebook, began writing observations. The M18 represented something new in armored warfare. Not just a vehicle, but a philosophy. The Germans had built tanks to win stand-up fights, to dominate through superior armor and firepower. The Americans had built the Hellcat to avoid stand-up fights entirely, to strike and fade, to never be where the enemy expected, to use speed as both weapon and defense. It was brilliant, and it was terrifying. Because if the Americans could build one vehicle with this philosophy, they could build 1,000. And if they could build 1,000, the German Panzer arm, for all its vaunted superiority, would be hunted to extinction by machines that refused to fight fair. Preparing and narrating this story took us a lot of time, so if you are enjoying it, subscribe to our channel. It means a lot to us. Now, back to the story. October 7th, 1944. A reconnaissance unit from the 21st Panzer Division reported something unusual near the village of Bessange-la-Petite. An M18 Hellcat, apparently abandoned, sitting in a muddy field beside a destroyed farmhouse. The report was met with skepticism. The Americans didn't abandon equipment, especially not intact equipment. It had to be a trap.
The Hellcat sat alone, engine cold, no visible damage. Lieutenant Hans Weber, the engineering officer, approached cautiously with a mine detector. Nothing. No tripwires, no explosives buried beneath, no signs of sabotage. The vehicle appeared to have simply run out of fuel and been abandoned by its crew in a hurry. Weber climbed onto the hull, peered into the open turret. The interior was cramped, Spartan, functional. No wasted space. Everything positioned for rapid operation. He noted the gun breech, the ammunition storage, the radio equipment. All American, all unfamiliar, all fascinating. "Get the recovery vehicle up here," he ordered. "We're taking this back." The operation took 4 hours. The Hellcat was remarkably light, perhaps 18 tons, less than half the weight of a Panther. The recovery crew marveled at how easily they could maneuver it. Even without power, even stuck in mud, the vehicle was manageable in a way German tanks simply weren't. By mid-afternoon, the captured M18 was rolling through German-controlled territory on the back of a transport truck, covered with tarps to hide it from American aircraft. Richter met the convoy personally at a secure maintenance facility 40 kilometers behind the lines. Finally, after weeks of chasing shadows, he had one of the Phantoms in his grasp. The examination began immediately. A team of engineers descended on the vehicle like surgeons on a patient. They measured, photographed, sketched, documented every detail. The hull was welded, not riveted, a faster production method. The armor was thin, as intelligence had suggested. Rolled, homogeneous steel, barely 25 millimeters thick in most places. A single hit from any German tank gun would be catastrophic. But then they examined the suspension, and the first surprise revealed itself. The M18 used a torsion bar suspension system, 5 road wheels per side, giving it remarkable ground clearance and stability. The tracks were relatively narrow but well designed, spreading the vehicle's light weight efficiently. The whole system was elegantly simple, requiring minimal maintenance. The engine compartment revealed the real secret: a Continental R975 radial aircraft engine, the same type used in the Sherman, but modified for higher output. 450 horsepower, driving a vehicle that weighed half what a Sherman weighed. The power-to-weight ratio was extraordinary, nearly 25 horsepower per ton. A Panther managed barely 15. "No wonder they move so fast," Weber muttered, making notes. "They're essentially strapping a light vehicle to an aircraft engine." The transmission was equally impressive. A hydromatic automatic transmission, similar to those used in American automobiles. No complex gear changing, no double clutching, no expertise required. A driver could simply put it in gear and drive. The simplicity was almost insulting compared to the sophisticated but temperamental German systems. Over the next 3 days, they tested everything they could without actually starting the engine. They didn't have fuel that matched American specifications, and they weren't willing to risk damaging their prize with improper operation. But they measured performance characteristics, analyzed the mechanical systems, studied the ergonomics. The crew positions told their own story. The driver sat front left, with excellent visibility through a simple hatch. The gunner and commander shared the turret, which could traverse 360 degrees rapidly thanks to a powered traverse system. The whole vehicle was designed for a crew of 5, but the arrangement allowed for incredibly rapid operation, no wasted movement, no unnecessary complexity. Richter compiled his findings into a comprehensive report. The M18 Hellcat, he concluded, represented a fundamentally different approach to armored warfare. Where German vehicles prioritized protection and firepower at the expense of mobility, the Americans had inverted the equation. The Hellcat sacrificed armor entirely in exchange for speed and agility. "The vehicle's armor provides protection against small arms fire and shell fragments only," he wrote. "Any direct hit from anti-tank weapons will result in catastrophic damage. However, the vehicle's exceptional speed and low profile make it an extremely difficult target to acquire and engage. In our testing of engagement times, we estimate that trained German tank crews require between 90 and 180 seconds to identify, track, and fire upon a moving M18 at combat ranges. The M18, based on observed tactical behavior, remains exposed for an average of 120 seconds per engagement. This leaves our crews with minimal margin for error." He paused, considering his next words carefully. "The M18's greatest strength is not its gun or its armor, but its refusal to fight on German terms. It engages at ranges and angles where our superior armor is irrelevant. It withdraws before our superior firepower can be brought to bear. In effect, it has rendered our technological advantages meaningless through superior tactical mobility." The report concluded with recommendations, most of them pessimistic. Tighter formations would make German units vulnerable to artillery and air attack. Aggressive pursuit would expose tanks to ambush. Better reconnaissance might help, but the M18s operated in areas supposedly already cleared. The only effective counter, Richter wrote, would be to develop similarly fast vehicles or to avoid engagement entirely. Neither option was available. Germany's industrial capacity was stretched to breaking. They couldn't design and build a new class of vehicle, and avoiding engagement meant surrendering territory, which meant losing the war. The captured M18 was scheduled for transport to Germany for more comprehensive testing, but it never made the journey. 2 weeks later, American forces overran the facility during a rapid advance. The Hellcat was recaptured by its original owners, who found it exactly where the Germans had left it, meticulously documented and carefully preserved. When American intelligence officers examined the German notes and photographs, they were surprised by the thoroughness of the analysis. The Germans had understood exactly what they were facing. They had identified the M18's strengths and weaknesses with remarkable accuracy, and they had concluded, correctly, that they had no effective counter. One American officer, reading through the translated reports, noted a single handwritten comment in the margin of Major Richter's final assessment. In German, barely legible, it read, "We are hunting tigers with rifles while they hunt us with automobiles. Speed has become armor. Mobility has become firepower. We are fighting yesterday's war." It was, perhaps, the most accurate assessment of armored warfare written during the entire conflict. The future belonged not to the heaviest armor or the biggest gun, but to whoever could strike first and disappear fastest. The Hellcat had proved it, and the Germans, for all their expertise, had no answer.
November 1944. The testing facility at Grafenwöhr, deep in Bavaria, had become home to Germany's collection of captured American equipment. Here, away from the chaos of the collapsing fronts, engineers could work methodically. The captured M18 had finally arrived, transported under heavy guard through increasingly dangerous skies. Ober-engineer Friedrich Hartmann stood in the cold morning air, watching as the Hellcat was unloaded. He was 52 years old, had designed components for the Panther, had worked on Tiger improvements, had spent 3 decades in automotive engineering. He thought he understood armored vehicles, but the reports from the front had shaken that confidence. The M18 sat on the concrete pad like a visitor from another world. Hartmann walked around it slowly, noting every detail. The welded hull construction was crude by German standards, but incredibly fast to produce. The armor plates showed no signs of the careful heat treatment German steel received. This was mass production armor, rolled out by the ton, good enough rather than perfect. But it was the proportions that fascinated him most. The hull was barely a meter high. The turret added another meter. A Panther stood nearly 3 meters tall. This American vehicle could hide behind terrain features that wouldn't conceal a German staff car. Low profile wasn't just an advantage in combat, it was a completely different design philosophy. "Get me the weight distribution analysis," Hartmann ordered his assistant. Within minutes, detailed measurements arrived. The M18 weighed 17.7 tons combat loaded. A Panther weighed 45 tons. The German vehicle was 2.5 times heavier, carried 3 times the armor, but couldn't move half as fast. The Americans had made a calculation that German engineers never would have accepted, that not being hit was better than surviving being hit. The first engine test came that afternoon. They had managed to acquire proper American fuel, 80-octane gasoline that German vehicles would have choked on. The Continental engine coughed once, then roared to life with a sound unlike any German tank engine. Smooth, powerful, confident. The radial configuration meant vibration was minimal. The whole vehicle barely shook. Hartmann climbed into the driver's position. The seat was simple, adjustable, designed for men of varying sizes. Typical American thinking, he thought. German tanks were built for specific crew dimensions. If you didn't fit, you didn't serve. The Americans built for whoever they had available. He engaged the transmission. The Hydromatic was a revelation. No clutch pedal, just a gear selector and throttle. He had driven cars with similar systems. General Motors had pioneered the technology in the 1930s, but putting it in a combat vehicle seemed almost frivolous. Except it wasn't frivolous at all. It meant any soldier who could drive a car could drive this tank destroyer. No lengthy training required, no specialist expertise needed.
Hartman pressed the throttle. The M18 leapt forward like a startled animal. The acceleration was shocking, physically pushing him back in his seat. Within seconds, they were moving at 30 kilometers per hour. Within 30 seconds, 50. The speedometer climbed past 60, past 70. On the test track, on good surface, the Hellcat reached 88 kilometers per hour before Hartman backed off the throttle, his heart pounding. "Impossible," he muttered, though he had just experienced it himself. No tracked vehicle should move this fast. The suspension should collapse, the track should throw, the whole system should tear itself apart. But the M18 just ran, smooth and stable, faster than many automobiles. Over the next week, testing continued. They drove it over obstacles, through mud, up steep inclines. They measured fuel consumption, engine temperature, transmission behavior. They pushed it hard, expecting failures, waiting for the American machine to reveal its weaknesses. The weaknesses never appeared. Oh, there were issues. The open-top turret meant the crew was vulnerable to artillery and small arms fire from above. The thin armor meant any hit would be catastrophic. The narrow tracks meant it struggled in deep mud. But these weren't failures. They were deliberate trade-offs. The Americans had sacrificed protection for speed, and they had made that sacrifice with engineering precision. Hartman compiled his observations into a technical report that read more like a confession than an analysis. The M18 represents a vehicle designed for a completely different doctrine of armored warfare, he wrote. German tanks are designed to hold ground, to win through superior protection and firepower in sustained combat. The M18 is designed never to be in sustained combat. It appears, fires, and withdraws before the enemy can respond. In this role, speed replaces armor, mobility replaces staying power. He paused, considering his next words carefully. This part would not be well received. Our vehicles are designed by engineers who think in terms of mechanical superiority. The M18 was designed by engineers who think in terms of tactical advantage. We build to win tank versus tank duels. They build to avoid duels entirely. In the context of modern fluid warfare, their approach may be superior to ours. The report went up the chain of command and was met with predictable resistance. German armor doctrine had been built on the idea of qualitative superiority. One German tank should defeat multiple enemy tanks through better design. The idea that avoiding combat could be better than winning combat challenged fundamental assumptions. But the officers at the front didn't need reports to understand. They were living the reality every day. The Hellcats were systematically destroying German armored formations, not through superior combat performance, but by refusing to fight on German terms. It was brilliant, infuriating, and utterly effective. By December 1944, the German army had documented 247 separate engagements involving M18 Hellcats. The pattern was consistent across all reports. The Americans had developed a tactical system optimized entirely around the Hellcat's speed advantage, and it was devastating. Hauptmann Werner Steiner commanded a training unit responsible for preparing replacement crews for the Western Front. He had been pulled from frontline duty specifically to pass on lessons learned from fighting the Americans. His classroom was a former factory building in Paderborn, cold and drafty, filled with young men who would be dead within weeks if they didn't understand what he was teaching. Forget everything you learned about tank combat, Steiner began his lecture, facing 40 attentive faces. The Americans are not fighting that war. They have changed the rules, and if you don't adapt, you will die. He pulled down a large tactical map showing a typical engagement scenario. The M18 Hellcat operates in teams of 2 to 4 vehicles. They never attack alone. They position themselves at multiple points around your expected route of movement. They wait. Patience is their weapon as much as speed. He marks several positions on the map with red symbols. When you enter the engagement zone, the first Hellcat fires from your flank or rear. Not at your strongest armor, always at your weakest. The shot is aimed to kill, not to disable. They target ammunition storage, fuel tanks, engine compartments. One shot,
One kill is their doctrine. A young lieutenant raised his hand. Then we return fire, yes? We destroy them. Steiner shook his head. By the time you traverse your turret to face the threat, the Hellcat is already moving. Not just moving, fleeing at 70 or 80 kilometers per hour. Can any of you tell me how fast a Panther can traverse its turret? 15 seconds for a full 360-degree rotation, Herr Hauptmann. Correct. 15 seconds with powered traverse, longer manually. In those 15 seconds, the Hellcat has moved more than 300 meters. By the time your gun is oriented, you're aiming at empty space. And while you're trying to find the first Hellcat, the second one opens fire from a completely different direction. He let that sink in, watching the realization dawn on their faces. The Americans call it shoot and scoot. We have a different name for it. We call it dying. Steiner moved to a blackboard, began drawing diagrams. The M18 speed gives it a tactical mobility advantage of approximately 3-to-1 over our vehicles. For every kilometer we move, they can move 3. This means they can reposition faster than we can react. They can appear where we don't expect them. They can withdraw from any engagement that turns against them.
He drew arrows showing movement patterns. They use terrain differently than we do. A hill that protects us from frontal fire becomes their staging point. They position themselves on the reverse slope, invisible to us. When we crest the hill, they're waiting 200 meters away at point-blank range. They fire, then accelerate down the reverse slope and disappear before we can respond. One of the students spoke up, his voice uncertain. What about ambushing them, setting up defensive positions and waiting? A valid tactic, Steiner acknowledged, but the Hellcat's speed means they can probe your positions, identify them, and withdraw before you can inflict damage. And once they know where you are, they call in artillery or airstrikes. The Americans have resources we don't. They use the Hellcat as a reconnaissance and target designation platform as much as a tank destroyer. He pulled out a folder of photographs, passed them around. Combat images, most showing destroyed German vehicles. Notice the penetration points. Almost always side or rear armor. The Americans don't waste ammunition on frontal shots, unless they have no choice. They position themselves where your armor is weakest, then they strike. The photographs told a brutal story. Panthers torn open like tin cans. Tigers with their thick rear armor penetrated. Even the massive jagged Panther tank destroyers, destroyed from angles their designers never anticipated. The Americans had found the seams in German armor doctrine and exploited them ruthlessly. So how do we fight them? Another student asked. There must be countermeasures. Steiner was quiet for a moment. This was the hard part. Honestly, we don't have good answers. Tighter formations make us vulnerable to artillery. Dispersed formations mean individual tanks can be kicked off. Aggressive pursuit means exposing ourselves to ambush. Defensive positions means surrendering mobility. He paused, choosing his words carefully. The best advice I can give you is this: never travel alone. Always have infantry support to spot for you. Use terrain to limit sight lines and approach angles. Move quickly through open areas. And pray the weather is bad enough to ground their aircraft. Because if you're fighting Hellcats, you're usually fighting American fighter bombers at the same time. The room had gone very quiet. These young men had joined the Panzerarm, expecting to crew the best tanks in the world, expecting qualitative superiority would overcome numerical disadvantage. Now they were learning that their advantages meant nothing against an enemy that refused to engage on equal terms. One more thing, Steiner added, his voice hardening. When you encounter a Hellcat, you have approximately 3 minutes from first contact to either destroy it or watch it disappear. 3 minutes. In that time, you must identify the threat, traverse your gun, acquire the target, range it,
and fire. Meanwhile, it's moving, changing position, possibly already shooting at you. 3 minutes is not much time.
He met their eyes one by one. Most crews don't survive their first encounter. They freeze, they panic, they waste those 3 minutes trying to understand what's happening. The crews that survive are the ones who react instantly, who fire at where the Hellcat will be rather than where it is, who accept that they might only get one shot. The lecture continued for another hour, covering specific scenarios, tactical responses, recognition features. But the core message remained the same. The Americans had built a weapon system specifically designed to counter German armor superiority, and it was working. That evening, Steiner sat in his office, writing a report to his superiors. The replacement crews were getting younger, less experienced, more poorly trained. Germany was running out of skilled tankers. Meanwhile, the Americans were fielding weapons that required less skill to operate but achieved better results. It was an equation that only ended one way. He thought about the M18, about its design philosophy. The Americans had looked at armored warfare and asked a different question than German engineers. Not, how do we build the best tank, but how do we kill enemy tanks most efficiently? The answer they found didn't require thick armor or massive guns. It required speed, mobility, and tactics. In a way, it was the perfect weapon for America's approach to war. They didn't have centuries of military tradition to constrain their thinking. They approached warfare like engineers approaching an industrial problem. Identify the goal, find the most efficient solution, scale it up, and execute. The M18 Hellcat was that philosophy made metal. January 1945. Berlin was dying, though few would admit it openly. In a bunker beneath the Reich Ministry of Armaments, a meeting was taking place that would never appear in official records. Albert Speer, Minister of Armaments, had called together his senior production engineers and military liaison officers. The topic was American industrial capacity, specifically their ability to produce vehicles like the M18 Hellcat. Speer opened the meeting with characteristic bluntness. "Gentlemen, we need to understand exactly what we're facing. Not the tactical situation, we know that's deteriorating. I need to understand the industrial situation. How are the Americans producing these vehicles? How many can they build? And most importantly, can we match their production?" Ober-Ingenieur Ludwig Hoffmann stood to present his findings. He had spent 3 months analyzing captured American equipment, reading translated intelligence reports, studying industrial photographs. His report was comprehensive and deeply troubling. "Herr Minister, the American approach to tank destroyer production differs fundamentally from our own. The M18 Hellcat is not precision engineered like our vehicles. It is designed from the start for mass production. Every component is selected based on availability and ease of manufacture."
He displayed a series of technical drawings. The hull is welded, not bolted or riveted. This requires fewer man-hours and less skilled labor. The armor is simple rolled steel, not face-hardened or specially treated. Again, faster to produce, less skilled labor required. The engine is an existing aircraft design, already in mass production. The transmission is adapted from civilian automobiles. The Americans are not designing new systems. They're adapting existing industrial production to military needs. Speer leaned forward. "Production numbers. How many have they built?" Hoffmann consulted his notes. Intelligence estimates suggest the Americans produced approximately 2,500 M18 Hellcats between July 1943 and October 1944. Production continues at roughly 200 units per month. The vehicles are manufactured by Buick Motor Division, a civilian automotive company. The room was silent. Germany's entire production of all tank destroyer types in the same period was perhaps 3,000 units, and that had required every heavy machinery manufacturer in the Reich working at capacity.
A civilian automotive company, Speer repeated slowly. They gave this to an automobile manufacturer? Yes, Herr Minister. The Americans have fully integrated their civilian industrial base into military production. Ford builds B-24 bombers. General Motors builds trucks, tanks, and aircraft engines. Chrysler produces tanks and anti-aircraft guns. Their entire automotive industry has been converted to war production. But because they're using automotive production techniques, the conversion was rapid and efficient. Hoffman displayed photographs of American factories. Vast assembly lines, standardized production, workers performing repetitive specialized tasks. They use what they call the assembly line method. Each worker performs one specific task, becomes extremely efficient at that task, then passes the work to the next station. A complete M18 can be assembled in approximately 4,000 man-hours. A Panther requires approximately 55,000 man-hours. The numbers were devastating. Even if Germany had unlimited resources, they couldn't match American production efficiency. The Americans had spent decades perfecting mass production in their automotive industry. Now they were applying those same techniques to military equipment, and the results were overwhelming. There's more, Hoffman continued, his voice quiet. The Americans designed the M18 with maintenance in mind. The engine can be removed and replaced in the field in approximately 4 hours. The tracks can be changed in 2 hours. The transmission can be swapped out in 6 hours. Compare this to our vehicles, where major component replacement requires factory facilities and multiple days of work. He pulled out a captured American technical manual, translated into German. They provide detailed maintenance manuals to every crew, step-by-step instructions with illustrations. A crew with basic mechanical knowledge can perform significant repairs without specialized tools or training. Our manuals assume the crew has technical expertise and access to proper equipment.
Speer was reading through production reports, his face darkening. So they build them faster, maintain them easier, and field them in greater numbers. What about quality? Surely our superior engineering counts for something. Hoffman hesitated. This was the difficult part. Herr Minister, quality is a relative term. Yes, our vehicles are more precisely engineered. Our armor is better treated. Our guns are more accurate. But the Americans have achieved something perhaps more valuable: consistency. Every M18 that rolls off their production line meets the same standard. Parts are interchangeable between vehicles. A transmission from one Hellcat fits perfectly in any other Hellcat. He paused, letting that sink in. Our vehicles, because they're built by different manufacturers using slightly different techniques, lack this interchangeability. A Panther built by MAN may require different parts than a Panther built by Daimler-Benz, even though they're theoretically the same vehicle. The meeting continued for another 2 hours, examining every aspect of American production. The picture that emerged was of an industrial system optimized for warfare in a way Germany's had never been. The Americans had standardized everything: parts, procedures, training, maintenance. They had designed their equipment not for individual excellence, but for system-wide efficiency. As the officers filed out, Speer remained seated, staring at the production charts. Germany was being outbuilt, outproduced, and outsustained by an enemy that had turned warfare into an industrial process. The M18 Hellcat was just one example. The same principles applied to their aircraft, their trucks, their rifles, their entire military machine. He thought about the Panther, the Tiger, all the magnificent German vehicles that broke down after 100 kilometers. They were masterpieces of engineering, each one. But the Americans had understood something German engineers hadn't. In modern warfare, 10 reliable machines were worth more than one perfect machine. 100 simple machines were worth more than 10 complex ones. The war was lost. Not on the battlefield, though that was certainly happening. It was lost in the factories, in the assembly lines, in the fundamental philosophy of industrial production. Germany had tried to out-engineer its enemies.
America had simply outproduced them. March 1945. The war in Europe had weeks left, though die-hard officers still spoke of miracle weapons and impossible victories. At a damaged testing facility near Stuttgart, the captured M18 Hellcat sat in a shed, protected from Allied air raids. Major Otto Richter, the intelligence officer who had first compiled reports on the vehicle, sat in his office writing a final assessment. Outside, he could hear artillery in the distance. The Americans were perhaps 50 kilometers away, advancing steadily. Soon they would recapture their tank destroyer, and all the German analysis would become historical footnotes. But Richter felt compelled to finish his report, to document what they had learned. The M18 Hellcat, he wrote, represents a fundamental shift in armored warfare philosophy. It succeeds not through superior engineering, but through superior doctrine. Speed has become its armor. Mobility has become its firepower. The vehicle itself is mechanically simple, even crude by our standards, but the tactical system built around it is sophisticated and devastatingly effective. He paused, considering his experiences over the past 6 months. All the destroyed Panthers, the confused reports, the desperate attempts to counter a weapon that simply refused to fight fair. We approached tank design as a problem of mechanical engineering. How thick should the armor be? How powerful should the gun be? How can we build the perfect fighting vehicle? The Americans asked different questions. How can we destroy enemy tanks most efficiently? How can we minimize our own losses? How can we build enough vehicles to win the war? The answer they found didn't require innovation in armor or weapons. It required innovation in thinking. The M18 succeeds because it was designed for the war being fought, not the war German doctrine anticipated. We built vehicles for set-piece battles, for holding ground, for dominating through firepower. The Americans built vehicles for fluid warfare, for rapid advances, for striking and moving. He looked at his notes from months of testing and analysis. Technical specifications. The M18 achieves 88 km per hour road speed, 55 km per hour cross-country. Armor, 25 mm maximum, inadequate against any anti-tank weapon. Armament, 76 mm M1A1, capable of penetrating 150 mm of armor at 500 meters. Crew, 5 men. Minimal training required. Production time, 4,000 man-hours. Cost, approximately $55,000 per unit. He compared these numbers to the Panther. By contrast, our Panther achieves 46 km per hour road speed, 25 km per hour cross-country. Armor, 80 mm frontal, 40 mm side. Armament, 75 mm KWK-42, slightly superior to the American 76 mm. Crew, 5 men. Extensive training required. Production time, 55,000 man-hours. Cost, approximately 117,000 Reichsmarks per unit. The comparison was stark. The Americans built simpler vehicles, built them faster, built them cheaper, and built them in quantities Germany couldn't match. And those simpler vehicles were winning the war. Tactical conclusions, Richter continued. The M18's speed advantage creates a tactical mobility differential that negates our armor superiority. German crews require 90 to 180 seconds to acquire, track, and engage an M18. The M18 remains exposed for an average of 120 seconds per engagement. This minimal margin means crew quality becomes critical. Veteran crews might successfully engage. Replacement crews, increasingly common in late-war Germany, have minimal chance of success.
He thought about all the young men he had trained, sent to the front,
watched die in vehicles that were supposed to be superior. The 3-minute rule, from first contact to escape. An M18 engagement lasts approximately 3 minutes. In this window, German crews must overcome surprise, identify the threat direction, traverse their gun, acquire the target, calculate range and lead, and fire. Meanwhile, the M18 crew, operating from prepared positions with pre-planned withdrawal routes, needs only to fire and accelerate. The tactical advantage is insurmountable. Richter's final paragraph was perhaps the most honest assessment written by any German officer during the war. We lost the industrial war before the first shot was fired. We lost the tactical war by fighting according to doctrine while the enemy wrote new rules. The M18 Hellcat did not defeat German armor through superior technology. It defeated us by making our technology irrelevant. Speed defeated armor. Mobility defeated firepower. Simplicity defeated sophistication. These are lessons we learned too late. He signed the report, dated it March 15, 1945, and placed it in a folder with all his other analyses. In 4 weeks, American troops would find these documents and translate them. They would read German assessments that praised American equipment while documenting Germany's inability to counter it. Some American officers would be surprised by the thoroughness of the analysis. Others would simply nod, knowing that understanding wasn't enough. Germany had understood perfectly what they were facing. They simply couldn't do anything about it. The M18 Hellcat would continue serving long after the war. It would fight in Korea, would be exported to dozens of nations, would serve well into the 1970s in some armies. Its design principles, speed and mobility over protection, would influence tank destroyer doctrine for generations. But its greatest victory was already complete. In the hedgerows of France, in the forests of the Ardennes, in the final battles for Germany itself, the Hellcat had proved that modern warfare belonged to whoever could adapt fastest. The Germans had built magnificent machines and learned hard lessons. The Americans had built simple machines and written the future of armored warfare. Richter closed his folder and walked outside. The artillery was closer now. Within days, maybe hours, American tanks would roll through these gates. Perhaps even a Hellcat, moving at impossible speeds, appearing from nowhere, the phantom that had haunted German tankers for the last year of the war. He found himself almost looking forward to it. After all this time studying the vehicle, analyzing it, understanding it, he had developed a strange respect for the machine and the men who built it. They had seen the problem clearly and solved it elegantly. That was good engineering, even if it had been used to destroy his country's army.
The American approach had been pragmatic, where Germany's had been idealistic. They had built good enough equipment in vast quantities, rather than perfect equipment in limited numbers. They had trained adequate crews quickly, rather than expert crews slowly. They had won through efficiency, rather than excellence. It was, Richter thought, a very American way to fight a war. And it had worked.